This is lesson 3.2, solving linear equations by graphing. Your objectives are to solve equations by graphing and to estimate solutions to linear equations by graphing. You can solve an equation by graphing the related function. The solution of the equation is the x-intercept of the function. The x-intercept is also called a zero because y is 0 at that point. For example, that point on the example question, the x-intercept has a y value of 0. When y equals 0, whatever x is the solution. And when we graph these, we're looking for the point on the graph where it crosses the x-axis. That's called the solution, and since it happens when y equals 0, it's also called a zero. Example: solve the equation 2x minus 2 equals negative 4 by graphing. The way to do this is you set the equation equal to 0. Then replace 0 with f of x. Remember, f of x is the same as y. And then make a table, and you'll graph that table. So if you look in their work, they have 2x minus 2 equals negative 4. They want a 0 on one side, so they move the negative 4 to the left by adding it to both sides. That gives you 2x plus 2 equals 0. Well, they replace the 0 with f of x, giving you f of x equals 2x plus 2. Now make a table. Just like before, the first column is a set of x values. The second column is whatever y equals, which in this case is what f of x equals, because remember, f of x is the same as y. The next column is what f of x or y is. You just put that value once you've worked it out. And then the last column says x comma f of x. And that's just like saying x comma y, because remember, y equals f of x. Now they used the x values 1, negative 1, and negative 2. We're going to use the x values negative 1, 0, and 1, and that'll keep a good standard graph to do. We'll have a little bit to the left and a little bit to the right of the y-axis. So they go ahead and substitute the x values in, solve for f of x, and you get a set of points. They have 3 points. They plot those 3 points, and then our answer is going to be the x-intercept. Remember, that's what happens when y is 0. The x-intercept is negative 1, so that's what x equals. Our final answer is x equals negative 1. So set the equation equal to 0, replace 0 with f of x, make a table, plot the points, and the x-intercept is your final answer. Solve each equation. Number 1. 3x minus 3 equals 0. Remember, we're solving for x. Set the equation equal to 0, which it is. Everything is all on one side of the equal sign. And then replace the 0 with f of x. So I really have f of x equals 3x minus 3. Now make a table. An x column, an f of x equals 3x minus 3 column. When we work that out, we'll have an f of x column, and then finally a x comma f of x column. Remember, f of x is the same as y, so I've got x's, I substitute in, solve for the y's, and then I have a set of points x comma y. We use f of x because we know this is a function. We're substituting in an x value, and we're finding out the function's y value. it's a good idea to just use -1, 0, and 1 for your x values. You can use any points you want to, but if you use those 3 points, that'll give you a good set of points to connect and then finish the question. So substitute in -1. F of -1 is 3 times -1 minus 3, which is -3 minus 3, which is -6. So we have a point, -1, -6. When x is 0, find f of 0, which is 3 times 0 minus 3. 3 times 0 is 0, and 0 minus 3 is -3. So our next point is 0, -3. When x is 1, find f of 1, which is 3 times 1 minus 3. 3 times 1 is 3. 3 minus 3 is 0. So we have the point 1, 0. Now let's plot those points. -1, -6 goes just a hair off the graph. 0, -3 is right there. And 1, 0 is right there. Connect the dots. Now where's the x-intercept? It's right there, with the x value of 1. So for this equation, x equals 1. Once you have plotted the points and graphed the line, find the x-intercept, and that's your solution, and that's your final answer. For number 2, if your graph is already drawn, ignore that because that is a mistake. So let's pretend the graph is empty. -2x plus 1 equals 5 minus 2x. Let's get everything on one side so that there's a 0 on one side. So first, to move the x's, I have -2x on the left. Let's add it to both sides. -2x plus 2x is 0, leaving a 1. And on the right, -2x plus x is a 0, leaving a 5. So 1 equals 5. I remember something before saying what happens when the variables disappear and I have something that's not true. Do you remember what that was? Let's continue moving things. We can subtract 1 from each side. And 0 equals 4. Now I have a 0 on one side. That's what f of x is. So f of x equals 4. Make your table. X, f of x equals 4, f of x, and then the ordered pair, x comma f of x. Remember my x values are -1, 0, and 1. And now I'll substitute each of those in. Be aware that this is going to look a little bit weird. Just go with it. F of -1, there's nowhere to substitute the -1, so it's still just a 4. That f of x value is 4, so I have the ordered pair -1, 4. When x is 0, f of 0, there's still nowhere to substitute the x, so that's still a 4. The same is true for f of 1. That's still a 4. For all of these, no matter what the x value is, the y value is 4. When you put anything into the function, it spits out a 4. So now I'll plot those points. -1, 4, 0, 4, and 1, 4, giving me a horizontal line right there. The solution is the x-intercept, but the line never crosses the x-axis, so there is no x-intercept. There is no solution. And if you remember, when we were back here at 1 equals 5, remember when the variables cancel out and you have a false statement, then there is no solution, and it works just the same here for the graph. Number 3, negative x plus 4 equals 0. Well, I already have everything on one side, and I have a 0 on the other side. So we can go ahead and replace the 0 with f of x. So f of x equals negative x plus 4. I can make my table, the x column, the f of x equals negative x plus 4 column. Whatever that turns out to, f of x, remember that's your y value, and then the ordered pair x comma f of x, which is really x comma y. Remember to use the x values negative 1, 0, and 1, and substitute in. For negative 1, f of negative 1 is negative 1, be careful there, plus 4. Negative of negative 1 is positive 1. 1 plus 4 is 5, giving you the ordered pair negative 1, comma 5. When x is 0, find f of 0, which is negative 0 plus 4. Negative 0 is just 0. 0 plus 4 is 4. So we have the ordered pair 0, comma 4. When x is 1, find f of 1, which is negative 1 plus 4. Negative 1 plus 4 is 3. So we have the point 1, comma 3. We can plot those 3 points and connect the dots. And remember, the x-intercept is my solution. That's where y is 0. That's why the solution is also called a 0. The x-intercept is right there, and that's where x equals 4. So the final answer, x equals 4. Remember, that's called the solution, and it's also called a 0. It's called a 0 because that's where y equals 0. Number 4. 0 equals 4x minus 1. Well, I already have a 0 on one side and everything else on the other, so let's go ahead and replace the 0 with f of x. Remember, I'm replacing the 0 with f of x because I want to know what x is when y is 0. What is x when f of x is 0? Make your table, your x column, your f of x equals 4x minus 1 column, whatever that result is for your f of x column, and finally your x comma f of x column for your set of ordered pairs. X will be negative 1, 0, and 1. When x is negative 1, f of negative 1 is 4 times negative 1 minus 1. 4 times negative 1 is negative 4. Negative 4 minus 1 is negative 5. So you have the ordered pair negative 1, comma negative 5. When x is 0, find f of 0, which is 4 times 0 minus 1. 4 times 0 is 0. 0 minus 1 is negative 1. So you now have the point 0, negative 1. When x is 1, f of 1 is 4 times 1 minus 1. 4 times 1 is 4. 4 minus 1 is 3. And the next ordered pair is 1, comma 3. So plot those points, negative 1, negative 5, 0, negative 1, and 1, 3. and connect those dots. The solution is the x-intercept, which is where y is 0, right there. That's between 0 and 1. That value is actually 1/4. The reason I know that's 1/4 is because if you solve the original equation, add 1 to each side, giving you 1 equals 4x, and then dividing both sides by 4, giving you x equals 1/4. Now ultimately you might only know that x is between 0 and 1, but if you want to go back and solve the original equation, you can get that exact value, and it will show on the graph. Number 5. 5x minus 1 equals 5x. Well, let's get everything on one side. I have 5x's on the right. Let's subtract those from both sides. On the left, 5x minus 5x is 0, leaving a negative 1. On the right, 5x minus 5x is 0. And I have it again. The x's are gone, and I have a false statement. You remember what the answer is? Let's replace 0 with f of x. So I have f of x equals negative 1. And make the table. An x column, an f of x equals negative 1 column, an f of x column, and an x comma f of x column. Remember, x is negative 1, 0, and 1. No matter which of these values you substitute in, there's no x to substitute it in for. So f of x is still negative 1, no matter what. When x is 0, f of 0, still negative 1. The point 0, negative 1. When x is 1, f of 1, still negative 1. No matter what x is, y is negative 1. Plot those 3 points. Negative 1, negative 1, 0, negative 1, 1, negative 1. Connect the dots. Your solution is the x-intercept. The line never crosses the x-axis, so there is no x-intercept. There is no solution. Remember when we had negative 1 equals 0. That's a false statement. No solution. Number 6. Negative 3x plus 1 equals 0. Well, it's already solved for 0, so let's replace the 0 with f of x. f of x equals negative 3x plus 1. Now make your table. Your x column, your f of x equals negative 3x plus 1 column, your f of x column, and your x comma f of x column. Remember, that's your x comma y column, because y and f of x are the same thing. X is negative 1, 0, and 1. Then we'll substitute those x values in and solve for y, which is f of x. When x is negative 1, f of negative 1 is negative 3 times negative 1 plus 1. Negative 3 times negative 1 is 3. 3 plus 1 is 4. So you have the point negative 1 comma 4. When x is 0, f of 0 is negative 3 times 0 plus 1. Negative 3 times 0 is 0. Plus 1 is 1. So 0 comma 1 is the next point. When x is 1, f of 1 is negative 3 times 1 plus 1. Negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So you have the point 1 comma negative 2. You now have your 3 points. Plot them on the graph. Negative 1, 4, 0, 1, 1, negative 2. And connect the dots. The solution is the x-intercept, which is right there. It's between 0 and 1. That actually has a value of 1/3. And the reason I know that's 1/3 is because I solved the original equation just to make sure. If you look at it, negative 3x plus 1 equals 0. You can subtract 1 from each side, giving you negative 3x on the left and negative 1 on the right. And when you divide both sides by negative 3, the negative 3's cancel on the left, leaving x, and negative 1 divided by negative 3 is a positive 1/3. So when you do these, if it's between two numbers, you can solve the original equation and get that exact value if you want. So just remember, for all of these, get your equation set equal to 0, and to do that, get everything on one side with a 0 on the other side. Replace the 0 with a f of x and make your table. An x column with negative 1, 0, and 1. An f of x equals whatever it equals column. An f of x column, and your ordered pair column. Work those out, plot the points, and the x-intercept is going to be your final answer.